before you start,
Oh,
I was
sorry.
going to mention, because there's no other students, and I think it makes sense for me and Megan to not provide you feedback during the recording,
No problem.
so we don't color the students' feedback.
Okay. I sort of have a predicament. If I'm recording on MS Teams right now, will you be able to see my screen? And will the screen be recorded? Do you know? Yeah? Okay.
Yes to both.
Thank you. Okay, well, I guess we can get started then.
So I'll kick things off. So for our MSCI 402 project, we're going to be consulting for CodeGem. And so a quick overview of our agenda. We're going to start off just quickly looking at our team. It's the same as before, and then look at a problem analysis as a refresher. And then we're going to go over what's changed since MSCI 401, go through the updated requirements, and then finally finish off with the roadmap. So looking at the team. So the members are the same as our previous project, and then our advisor is still Jesse. So the problem we're tackling is poor management in the software space, and specifically we're focused on the inefficiencies caused by poor productivity and poor collaboration, as well as the high cost and high rate of turnover in software teams. So current solutions today really fall into two categories. On one side of the spectrum, there's analytic tools, which really focus on collecting productivity metrics and are geared towards the manager. On the other side of the spectrum, there's HR software solutions, which are more focused on the engineer, but rely completely on feedback and capture only satisfaction metrics. So what we're trying to do with CodeGem is combine the value of both of these together in one place. So the one-liner for CodeGem is management software built to optimize engineering teams. And so what CodeGem does is, first of all, we could go to the next slide, is capture data from the tools software engineering teams are using to collaborate. And so they're collecting data on productivity, collaboration, and also satisfaction. And then we use that combined information to generate analytics that give managers the full picture of their team. But currently, CodeGem only collects metrics on productivity and collaboration. We don't have a way to pull in that satisfaction data. And so our need statement is, CodeGem needs a way to measure and improve software team engagement to reduce turnover.
So the updates we've made since MSCI 401, our scope has shifted a little bit. Initially in MSCI 401, we wanted to set and measure goals as an engineer on the individual level. So providing functionality around goal measurement, a framework, all within the individual level of an engineer. But now with MSCI 402, we've shifted our scope a little bit to measure the satisfaction and engagement of engineers through peer feedback. So really emphasizing the peer feedback piece, where we want to base most of our analytics on and our goal measurement on feedback alone. So we're doing that via surveys, which Lulu will show you later on as well. The data collection updates we've made. Initially in 401, we were managing our goals in a web app and monitoring this progress with GitHub integration. So really focusing on the web app piece outside of the GitHub platform. But now we want to insert the interface directly into GitHub via these surveys, actually via Chrome extension, and use NLP to describe communication automatically. So going on that deeper level of understanding the peer feedback piece to measure our goals. And then the analytics have shifted, where initially we're tracking goal setting, goal progress, success, and failure. And now we've shifted over to focusing on the engineer's well-being, doing some pulse check-ins, as well as looking into the given and requested peer feedback in GitHub that we weren't initially tracking in 401, and also going deeper in that level with communication trends using NLP.
So our updated roadmap. The next slide. So this slide shows our design principles that we determined last term that we followed through our requirement gathering and designing process this term as well. In our design sessions from last term, we used a method called a method of brainstorming called empathy mapping. here's the slide, to understand our users' wants and needs. This term, we use those ideas and refine them to design for a solution targeting employee satisfaction. So we looked at case studies and articles and design ideas that highlighted the principles of employee engagement and found consistencies, which were the foundations for our survey design. We came up with basic requirements and determined that a bare bone workflow and in a form of a decision tree at first. And from there, we were able to translate that into our first set of wireframes. So the first set of wireframes were built for Slack integration. And we would have built it off of the CodeGem platform, and allows us to inject a CodeGem bot that targets specific users and can be triggered whenever an event such as like a PR closing occurs. Our first designs included a user mood pulse check, as well as like a peer feedback interface. It also prompted the user to select reasons from a list of predetermined common feedbacks and questions. And the questions are designed in a way that we can assign context to each point in time when the user checks in with the bot. This was done so that the feedback data can be processed and then provide useful analytics directly related to their work tasks for the CodeGem manager's dashboard. And we added space for the users to provide their own suggestions as well. And this is where we thought we would get the most constructive feedback. So we conducted about 20 plus user interviews and primarily user task analysis and cognitive walkthroughs to validate the design. And turns out that the questions were comprehensive, but we got other feedback related to how they wanted it to be iterated and designed. And the major takeaway was that they wanted it to be built in GitHub instead of Slack. And another major piece was that the engineers wanted an incentive piece, like why they should do these surveys. So our new designs are on GitHub, and they are implemented using a Chrome extension. These new designs directly are injected into the GitHub user interface, and it captures the data we want just as effectively, but without being intrusive into their engineers' like work. So here are some of the pieces of that new Chrome extension. So the mood check-in process can be enabled from like a persistent icon at the corner of the screen. We added a goal progression piece that's injected constantly on the GitHub interface to provide that incentive piece. So engineers can set their goals and how they want to track their goals, and also specify if they want which parts they want to be anonymous. And the cool part is that it ties straight into feedback that they will get from the reviewers. So reviewers will have more of a structured layout on the specific goals that the engineer that they are reviewing has asked for, and then that engineer can track their goals in their personal goal board. So a design challenge we're facing is whether we wanted a persistent check-in banner at the bottom, or what if we wanted event-based triggers. So we will be doing A/B testing to determine this. One other thing we wanted to capture was adding a more realistic range of emotion. We realized through interviews that the engineer's range of emotions was more than on just a linear point scale, and that an engineer can be two different emotions at once, hopeful and happy. And so depending on how an engineer would give their comments and communicate, different intentions and tones can be interpreted just by analyzing the way that they communicate the words individually and collectively. And so this leads to some of the natural language processing that Ian's been working on.
Yeah, so an important question that is crucial for measuring engagement and understanding engagement is basically understanding how engineers are communicating. And I think it's just important to note at the start here that there is no perfect way to communicate. There's absolutely a way to communicate effectively versus communicating ineffectively, but everybody has a different style. So what we're trying to do is just identify what that style is, and not make judgments about whether it's right or wrong. And the way we're doing that is really by focusing on something called a dialogue act. And so it can basically be anything like a question, requesting a change, providing praise. We've selected a few that we think are very relevant in software development, and we'll be looking at GitHub pull request text data. So this is where engineers are frequently giving each other feedback about the code they're writing and the processes they're using. What's interesting to note is that dialogue acts are not necessarily mutually exclusive. So you can have a request for a change phrased as a question. So this has affected kind of the method we've used for how we're going to actually measure their communication style. I can go to the next slide. Yeah, so in a high level, we're looking at the text data on a per sentence basis. We're using a pre-trained sentence BERT model that was based on a model built by Google a couple of years ago. And essentially what we do is we take an embedding of a sentence and use cosine similarity to compare it against an average embedding of each dialogue act. And so you can see examples at the bottom there of, there's the example, how does this work? It's very similar to a question. Therefore, when you aggregate this over time and over a lot of communication, you can start to see their styles. And so in terms of, you can go back, that was the right slide, Galen.
Sorry.
In terms of what value you can get out of the data and how you can visualize it, you can see that basically there's an average on teams. So, where would you expect most engineers to fit in terms of how they're communicating? You can see how it changes over time. So maybe something changes on the team or something changes about how the team works, and you can monitor if the communication is changing and whether it's changing in a positive direction or a negative direction. And most importantly, you can identify outliers. So a good example of an ineffective communicator is that developer in blue who is not necessarily communicating, the comment length is short, so they're not saying a lot. They're asking a lot of questions, but they're not requesting any changes or discussing. So in terms of a collaborative communicator, there's not much evidence of that happening here.
So moving on to our verification and validation processes. So in terms of the survey verification, all of our designs are based on online research taken from sources such as Google, where we designed our entire survey structure, the questions asked, the goal options we're giving users, based on these areas of topics, I guess. So we looked at key metrics of engagement for inspiration for survey structure and questions asked. And we also researched some code review best practices to ensure we're covering all of our bases in our survey options. So from MSCI 401, we also conducted a lot of user interviews and sent out some surveys as well to really verify our initial problem steps, problem space, and moving deeper into our verification of the design aspect at this point. In order to validate our survey alone, we're going to do some testing, A/B testing, cognitive walkthrough, where with the A/B testing, we'll be testing out functionality. So as mentioned before, Lulu said we have event triggers versus a persistent icon in the corner. So we'll be testing that to see the participation, the level of interactions on for each test group. And then we also want to provide a cognitive walkthrough to make sure that CodeGem's ease of use is intuitive, only because as for a survey, we don't see them having much training on our tool. So we want to make sure it's as intuitive and easy as possible so that when users are onboarded, they can go right into it right away.
And for the NLP validation, we're using a bit of a different process. Basically, we want to perform two types of tests. The first one will be kind of isolated experiments where basically you're taking software engineers who are familiar with GitHub code review, and you're going to show them just an independent example. Basically, here's a question, and then, here's an example, and then they'll say what they think the dialogue act or acts are and how similar they are to that. And they'll do that independently, and then we'll show them what the NLP produced, and we'll use that to compare the accuracy. And then for aggregate experiments, basically we want to present engineers with a collection of examples. So they'll look at basically, let's say 10 comments, for example, and try to have an idea, okay, this is how I think this person communicates. Then they'll take a look at how the NLP thinks that this person communicates, and we'll compare the accuracy of that as well.
So that really concludes our presentation. I just left this roadmap here as well to show you our progress and what we plan to have by the symposium date. So we already have designs verified, validated, and now we're at the implementation stage of the survey. And in addition to that, we'll be implementing our NLP and getting some data visualizations in place just to see the survey results, and then conducting some testing at the end as well. Any questions? Thank you.
I think you can stop the recording now.
Awesome.
That was well done.
Thank you.